So as we said at the end of the last video, 2 pi corresponds to 360 degrees. That is one full revolution around our circle where we're doing angle measure. So if we're going to go halfway around the circle, we said half of 360 was 180. So half a revolution in radians is pi. And so that's why it's pi radians. If we're going to go a quarter of the way, half of 180, a quarter of 360, then we take a full revolution, divide it by 4, and that's why 90 degrees corresponds to pi over 2. So we do this all the way around the circle, and we get those interesting measures that we like so much that we said were important to us in trigonometry. So we have 0 radians, no degrees, just radians. We have pi over 2. We have pi. And if I want 3/4 of a full revolution, that's going to look like 2 times 3 is 6 pi over 4, or 3 pi over 2. So 270 down here would correspond to 3 pi over 2 radians. And then one full revolution is 2 pi. So equivalent to 30 degrees. And we could say 30 degrees is what part of 360 degrees, and we can use that to multiply by our full revolution radians. So this is 1/12. So we're going to take 1/12 of 2 pi. That's 2 pi over 12, or pi over 6. And we do that all the way around our circle. This is equivalent to 45 degrees. This is equivalent to 60 degrees. Here's equivalent to 90, 180, and 360. So we can convert all of our degree measures to radian measures quite easily. And remember, what we like about radians is radians are real numbers. No approximation is present here. This is a real number angle measure. I don't need anything smaller than a radian. I don't need degrees or minutes or anything like that. So let's convert between degrees and radians in both directions. We can convert from degrees to radians by multiplying this multiplier. Let's say we want to convert, let's do 60 degrees. I want 60 degrees equivalently in radians. So this is 60 pi over 180. That is equivalent to pi over 3 radians. So let's do it in the reverse. I want the equivalent degree measure to pi over 3 radians. Well, that's pi's cancel, so that's 180 divided by 3, 60 degrees. So very simple, very straightforward to convert from degrees to radians or radians to degrees. So here it says convert the degrees to radian measure. So we want to wind up with something in terms of pi. And so that should help you remember, am I using this or am I using this? Well, I want pi in my final answer, so this is going to be my choice. So 60 times pi over 180 is pi over 3. 30 times pi over 180 is pi over 6. Negative 54 times pi over 180. Negative 54 pi over 180. Let's see. 9 goes in there. 6 pi over 20. That reduces again. Negative 3 pi over 10. And we could do the others. I'm not going to take time in the lesson, but we definitely could. So now let's convert from radians to degrees. And again, I want pi to disappear. So that's the one that tells me pi needs to be in the denominator. So I'm going to take this, multiply by 180 over pi, and I get 30 degrees. Take this, multiply by 180 over pi, from radians to degrees, 90 degrees. Take this, multiply by 180 over pi. That goes away. That's 10. The pi's go away. So that's negative 110 degrees, if I did the math right on that. So you get the idea. You just need to know those two multipliers. I'm either going from radians to degrees or degrees to radians. So we want to find one positive and one negative angle that's coterminal with angle theta, which is given in radians. So what we did a while ago, we took our angle measure and we either added or subtracted a full rotation. We did it in degrees, but it's the same process for radians. So I'm going to find a common denominator, 6 pi over 3. So this is equivalent to 7 pi over 3. Here I have pi over 3 minus 6 pi over 3. So that's negative 5 pi over 3. So the math is the same. We're just dealing with pi and with radian measure. So let's find the equivalent radian measures for all of these special angles given to us in degrees. So we know zero's easy. That's 0. 360 we've already talked about. 90 we've already talked about. 180 and 270. So those are done. So 30 degrees is equivalent to, remember, 30 times pi over 180 is pi over 6. And there's an easier way to figure out all the rest of these. If one 30-degree angle is pi over 6, then here's two of them. So that's 2 pi over 6. So that's going to be pi over 3. Here's 3 of them. 3 pi over 6 simplifies to pi over 2. Here's 4 pi over 6, or 2 pi over 3. 5 pi over 6, 6 pi over 6, 7 pi over 6. Here's 8 pi over 6, which reduces to 4 pi over 3. 9 pi over 6, 10 pi over 6, which is 5 pi over 3, and 11 pi over 6. So knowing that each one of these quadrants is broken up into 3 different 30-degree angle measures makes filling this out very quick. And we can do the same thing with 45 degrees. So 45 times pi over 180 simplifies to pi over 4. So let's do the same thing we just did a while ago. There's 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. So you don't have to do this for every single interesting angle measure around that circle. So we'll practice this turning degrees into radians, most especially because that's what we're going to use most of the time. From this point forward will be radian degree measure. We'll use it enough you'll get very, very comfortable with it. So that's it for your first trigonometry video lecture. Come to class next time and we'll work on this.